Hi there, it's the 12th day of the new year already. I believe I haven't done any breakdown since the new year 2014. I admit I've been quite lazy, but you know what? I've been preparing something great for all of you. I am now gonna do a special edition of breakdown on a series of permutation and combination question for the IBHL. I have been receiving requests to do something topic-wise, and I believe this is a good topic to start with because for any other topics, it would take probably too long to completely cover the whole topic and then cover some question. For permutation and combination, it happens that it's not too complicated. Okay, I know it's hard to get, I know it takes some practice, but the core concept is not that complicated. So this is what we're gonna do. We're gonna clear the concept and then we do a few questions together to make up this whole series of permutation combination selections. Okay, so we take the question aside. We start with some counting techniques, so to speak. Okay, so combination and permutation are strictly for counting. Okay, the first kind of question that you want to count are simply the number of ways to line up something. Okay, so let's say 4 people, okay, A, okay, B, C, and D, go to take a picture, line up. I know this is the classic example that all of you know. So 4 people go to line up, how many spots do you need? How many places do you need? Okay, first you draw the place. Obviously, you need 4 places. Okay, you have 4 people, and then you ask, how many people can you put into the first slot? How many choices are there? Obviously, since there are 4 people, you have 4 choices. Okay. Now on the line, I usually write down the number of choice instead of how many people I actually put there. Obviously, in one slot, I can only put 1 person. I cannot put 12 people there. So this is the number of choice. Now after I put somebody in the first slot, you're gonna ask in the second slot, how many choices are there? Since somebody already filled the first slot, you know that person would be gone. You cannot select him again. Therefore, of the second slot, obviously you have 3 choices. Then this slot, 2 persons are selected, so 2 choice, and then you got basically no choice. You got 1 choice only. Okay, and you're gonna ask, what are you gonna do to this 4 numbers? Then you're gonna do something called the AND rule and the OR rule. Okay, the AND rule or the OR rule. Simply put, AND means multiply, and OR mean plus. What does AND mean? AND simply means stepwise procedures that you're gonna do one after the other. It basically means and then. So in this lining up sequence, what we did is we line up the first slot and then consider the second slot and then the third slot. So this is obviously an application of AND rule, and we're gonna multiply these numbers together. What about OR? OR simply means you have 2 different ways of doing the same thing. You're considering 2 different cases. In those kind of situations, you're gonna add up the number of ways that you have for the 2 cases. For example, say one way you can do girl first, the second way you can do boy first, and then you're gonna count them separately and then add them up. So that's the OR rule. Now for here, we have 4 times 3 times 2 times 1. And I think all of you would know that we simply denote this as 4 factorial. Okay, 4 factorial. So, well, this is the first counting technique that you have, you know, the factorial. Factorial is simply for lining up stuff, and yeah, that's all. So after lining up, we have something called, we choose something. We select something of something. So let's say we have n objects. We're gonna select, okay, all objects out. You're gonna select all of them out. Okay, if you understand, you're gonna use one of the following. You're gonna either use P or use C. Okay, P for permutation, C for combination. Basically the name of this topic. So both of them are for selecting all objects out of n objects. Both of them are the same. So question, well, how are they different? The only difference is that for permutation, we say that order matters. Okay, while for combination, we say that order does not matter. Now you have to be very sure what does matter mean mathematically. When I say order matters, I mean if you swap the order, I would count the 2 as different ways of doing the same thing. I would count them twice if we swap the order. Okay. If order doesn't matter, I mean, even if we swap the order, I would consider that to be the same selection, and I would not count them again. A strict example of C where order doesn't matter is lottery. I believe for the whole wide world, true for Hong Kong, true for the US, I believe, that when you do lottery, you don't have to buy the correct order. When the balls comes out, okay, if you go and buy 1, 2, 3, 4, 5, 6, okay, while when the lottery comes out, if it happens to be 4, 3, 2, 5, 6, 1, obviously you still win the game. You still win all your money. But this means that order doesn't matter. Even if we swap the order, we think that they actually mean the same thing. Okay? While for permutation, we means that order matters. So, for example, let's say you go to the Olympic and you are buying who wins the gold medal, who wins the first runner-up, who is the second runner-up. In this case, that order would matter. Why? You can ask the athletes, okay, whether they're winning the gold medal and a silver medal means something to them, okay? With the same 3 person wins all the 3 prizes, but you have a different order, it's obviously different selections, different ways of giving out the prizes. So P would mean order matters, and C would be order doesn't matter. And the notation is usually written as NPR or NCR, although there are a number of ways of writing the same thing. For example, you can write NPR, NCR, they mean the same thing. For C, you can even write bracket, almost like a vector, but no. Okay? And in the formula booklet, you can actually find formulas for them. For permutation, you can find a formula booklet. The formula is n factorial over n minus r factorial. Factorial means what we did before, means 4 times 3 times 2 times 1, so on and so forth. While for NCR, the formula is n factorial over r factorial, n minus r factorial. Okay, during the formula booklet, since you're an HL student, you're gonna need how to use them. But unfortunately, I don't think I would cover too much of this inside this video. So that's basically it. Okay, you have P, you have C, and you have factorial. Factorial is for lining up. P and C are for selecting R objects from N objects. The only problem is whether order matters. Okay, so that's basically it. Now, but there's one note. Whenever you use P or C, there is one rule. There's one limitation to P and C. That is, for your N objects, they has to be all different. By different, we mean they're all distinguishable. That is, there are no 2 balls or 2 objects that when I pick one of them, you cannot tell if I pick this one or the other one. Okay, it's not like I have 2 identical red balls where if I pick the first red ball or I pick the second red ball, you really can't tell the difference. We do not accept cases like this for P and C. There's a good thing that in IBHL history, I don't think they ever do this. And in the new syllabus, start from 2014, they specifically say that all objects are distinguishable. That is, you can always use P or C, okay, so to speak. So that's all. Let's start some questions. The first selection that I pick is a 2012 time zone 2, I believe, paper 2 question. It's probably paper 2 because the NPR stuff can be pressed from the calculator. Okay, I really hope you know how to do that because I'm sorry I would not be able to show that in this video. I do not have the calculator with me right now, so I just show you the technique. Okay, so let's see what's going on in the question. You're gonna have people sitting on a single line. That basically means it's a line up question. Okay, you're gonna use factorial. You have 15 boys and 10 girls. Question: in how many ways can they be seated in a single line so that the boys and girls are in 2 separate groups? Okay. So this is a variation of a very classic kind of question. That is, some of them have to sit together. Okay, maybe 2 of them, 3 of them have to sit together. So whenever you have this, what you do is you're going to imagine that you tie the people who need to sit together. Okay, you're going to tie them up. So act like they're just one person or one lump of person. And you're going to line up with it. Okay, so what we're going to do is all the boys must be together. So we're going to have a row and tie all the 15 boys together. And we're going to tie all the girls together. So what we're gonna have now is just two lumps of people. Okay, so we're gonna line up the two slump, and you line up two objects. Okay, obviously you have two factorial ways to do it, because if you line up 4 objects, you get 4 factorial, right? After you line up the lumps, okay, you're gonna consider inside each tie. Okay, you tie up 15 boys. The problem is inside the group, the 15 boys can have different ways of lining up. You need to line up that 15 boys again. To line up 15 boys, we do 15 factorial. And then we line up the 10 girls again, 10 factorial. Note that I use multiplication in between because I'm doing a stepwise stuff. We'll first tie them up, and then I consider inside the tie. So this is an AND rule. So you're going to multiply them. You press calculator, you get the answer. Part B, 2 boys and 3 of the girls are selected to go to the theater. How many ways can that be made? Okay, we're doing selection. So obviously, we're doing P or C. Question, does order matter? Now you just go to a theater and probably watch a movie or something, right? The order probably doesn't matter if you just go and watch. Therefore, we would assume that this time we use C. So we need 2 boys. There are 15 boys that are available. So obviously 15C2. We need 3 girls and 10 girls are available. So 10C3. Next question, is this multiplication or add them up? Okay. Now it would be add them up if we are talking about we select 2 boys or 3 girls, which is not the case. Okay. This is AND. They're going to go together. So this is AND rule. We multiply them together. You take the calculator out, compute this number, you get the answer. Okay? So that's it for the first one. It's not too hard. It takes not much of a time to do it. Let's see another second question. It's also from 2012. This time it's from time zone 1, but it's also a paper 2 question. A team of 6 players to be selected from 10 players. Okay, 8 of them are boys, 2 of them are girls. A. In how many ways can the team be selected? They do not say any restriction, they do not say any limitation, just how many ways. You can see there are a total of 10 people. You choose 6 of them to be in the team. You select people, is P or C. You play as a team. The order probably doesn't matter because it's not like we are, assigned numbers or anything. We just put them into a team. We assume that order doesn't matter because it's a team. So therefore, we just do C, so 6C, 10C6. Simple as that. Press calculator, get the answer. Part B. It says, in how many ways in these selection we make if exactly 1 girl has to be in the team? Okay, this is a little bit more tricky. This is what we do. In the team, there are 6 people. So basically, we need 6 slots. 1, 2, 3, 4, 5, 6. We need exactly 1 girl. So let's say that I'm going to pick a girl in the first slot. Okay, so this is a girl, and the rest, they're boys. Okay, so question, how many choices do I have of this slot? Well, there are 2 girls. So in this slot, I have exactly 2 choices, either this girl or the other one. Next, of the 5 slots, I need to pick boys. I need 5 boys. There are 8 boys available in total. Therefore, there are obviously 8C5 choices. I choose this, and then I choose this. Therefore, it's an AND rule. 2 times 8C5 is the answer. Done. Okay. C part is just HL decide to be generous and give you 2 marks. If the selection is made in random, find the probability that exactly 1 girl is in the team. Probability of exactly having 1 girl is simply the number of ways of having exactly 1 girl. Number of ways. So it's called the number of favorable ways, right? Number of ways of exactly 1 girl over the total possible way. Why is this a generous mark giving out? Because it's obviously just the answer from part B divided by answer from part A. So, 2 mark for free. Well, that's it. Okay, we're gonna move on. And this one is a little bit harder. Not that much, but a little bit. 3 boys and 3 girls gonna sit on a bench, beach to do some photography. A number of ways can be done if all 3 girls must sit together. Okay, it's similar to the first one where some of them must sit together. So we use the same technique. We're gonna tie them up. Okay, So they are now together. So how many people are there? Since I would view these 3 titled up people as one person, I actually only have 3 people right now. So I line up these 4 people, sorry, 3 plus 1 is 4, is 4 factorial. Okay? And then I will consider inside the tie, how many ways can I line up these 3 people? Okay, the 3 of them, so 3 factorial. Multiply them together. This is obviously n, I don't think I need to explain this anymore. So that's it. B, find the number of ways that can be done if these 3 girls must all sit apart. Okay, this is quite hard. First, what you do not do is, do not think you can just do the total number minus part A. Because, now you can do this if part B is the exact opposite of part A. But it happens that it is not. Because the opposite of all 3 girls sitting together is not that all of them sit apart. Because even if it's true that they do not sit together, it could happen that 2 of them are together and then 1 is far, far away. While for this case, it doesn't count as all sit together. Therefore, we cannot just do total minus A. Okay? We will be counting too many cases. For example, something like this. So first of all, this way is out. So it seems that we really need to count. But if we try to actually count it, we can see there isn't too many ways of doing so. So there are 6 people again. We should draw 6 slots. We need the 3 girls to be sitting apart. So how can we do that? So let's assume that the first girl would sit on the edge, like here. So since they cannot be together, it seems that the other one must be probably here. And then the other one is probably here. This is one way. There's another way. This girl can go here, right? Is that all? Well, not really, because this middle girl can now go here. Okay, well, you can see that this and this is the mirror image of each other. If you put a mirror here, you just flip it, you get the other case. Okay, therefore, since we are already considering mirror image, let's do the mirror image of the first case as well. So the girl will sit on this edge, and then this. Okay, now you can see if we do not count, we do not consider which girl would sit on this slot, while just saying that this seat will be set by a girl, then this is all the ways. Okay, this is how we assign seat for the girls. Okay, the next question is just which girl would sit at the girl's place, which girl place, right? You can see that there are only 4 kinds of situations to do this. Okay, well, for each of it, okay, since these 3 places are occupied by girls, the other 3 must be boys. There's no choice, right? Boy must be here. So how many ways can I do this? Okay, so when the girls come, let's say, okay, girls, you sit first, right? Lady first, right? So, but I would say that, hey, I have already assigned that these 3 seats gonna be occupied by girls. So if you're a girl, you have to sit here. So it's basically like these 3 seats are not there for the girl, and they are just sitting, lying up on these 3 seats. Therefore, it would be exactly the same as just lying up 3 girls. So 3 factorial. After the girl is done, the boys are there. While the boys can only choose these 3 slots, it's the same. The girl that are there is kind of not there. It's not useful. Alright? So let's say no boys are involved with any girl, let's say. So they do not care. They just sit on these 3 seats. So it's kind of like lying up 3 boys. Again, 3 factorial. And since I do the girl and then the boys, they're multiplied together. Bear in mind that this is case 1. We have other cases like this, this, and this. By the same logic, you know, the 3 girls sit down first, and then the 3 boys must take these 3 seats. Same here. Same here. Now we have 4 huge numbers here. They're basically the same, but with 4 numbers here, do we multiply them together or add them up? Now this is n. This is OR rule. This is addition. Okay, because they are basically different ways for the 3 girls to sit all apart. Okay, therefore this is OR rule. You need to add them all up. And since you're adding up exactly the same thing 4 times, the answer is basically 3 factorial times 3 factorial times 4. You're adding this 4 times, okay? This is probably the hardest one that we're gonna do today. You can go home and review this technique, listing out all the possibilities, and then considering which girl would take which girl's seat, okay? And then add them all up, consider different cases, okay? So yeah, you're gonna take a look at this. And the very last one that I do, what happens to be a section B question. This question is quite fun because it's divided into 3 separate parts, A, B, C, while each part is totally not related, okay? The part where permutation and combination comes would be part B, okay? Part B is considering some polygons, okay? Distinct points of a circle forms polygons. So it's like you have some points, right? So basically a polygon. Diagonals can be drawn by joining all pairs of non-adjacent points. So that's the definition of diagonals. That is, if you just join any 2 points, you get a diagonal. Unless you join adjacent point. They're not called diagonals, they're called edge. The edge of the polygon, right? So they don't count as diagonal. Question is, A, they give you some insight to this question. Draw the diagonals if there are 5 points. Okay, so let's do that. Probably everyone can do this because you just draw. You just try to exhaust all the possibilities, and you're gonna end up with a star. Okay, this is just an insight for the second part. Okay, show that the number of diagonals is n times n minus 3 divided by 2 if there are n points. Okay, now you can see we do part 1 by beginning with 5 points. So 1, 2, 3, 4, 5. How many diagonals are there? So 1, 2, 3, 4, 5. There are 5. So if you plug 5 into the formula, seems like it works. 5 times 5 minus 2, 5 minus 3 is 2, divided by 2, so then you really do get 5, right? So the question is why? Why does this work? There are quite a few ways to prove this formula. It's basically a well-known formula in math society, so to speak. But the question is why, right? My favorite way is the following. How do we get diagonals, right? Now let me draw some points on the diagram, right? So, okay, a lot of points. Question is, how do I get a diagonal? To get a diagonal is quite simple. You pick any 2 points, you join it, you get it, you get a diagonal. You pick any 2 points, you join it, you get a diagonal. So in how many ways can I pick 2 points and join them? There are n points. I simply pick 2 points. Pick means select, right? So from these 2 points, I select 2 points. The question is, does order matter? Not really. I pick this and pick this, I draw the same line. I pick this, I draw the same line. Therefore, it seems that it doesn't matter which one I pick first, because I would come up with the same line. So order doesn't matter. So this is C. Any 2 points I pick, I draw a line, I get a diagonal. NC2. Is that the answer? Not really. I lie a bit. You cannot just pick any 2 points, because if you are so unfortunate that you pick 2 adjacent points, you do not get the diagonals. Alright? So this is over counting too much. You also, because if you just do NC2, you are also counting adjacent lines. Okay, that would be giving you an edge, not a diagonal. So that's not good. So you need to subtract in how many ways are you over counting. That is, how many edges are there? Well, if there are n points, it's an n-sided polygon, and so obviously there are n sides that you count, which are not diagonal. So it's NC2 minus n. If you go to the, bear this in mind, if you go to the formula booklet and get the formula for NC2, okay, you will see it's n factorial over 2 factorial over n minus 2 factorial minus n. Okay, so I said you wouldn't use this too many times, but for now, this is an occasion for you to use this formula. And let me show you how do you simplify something like this. This is how you do it. Consider the meaning of factorial, right? What is 6 factorial? It's just you start with 6, and then times one number less, times one number less, all the way until you hit 1. So that's the meaning of factorial. You start with n, like 6 you start with 6, so n start with n. Multiply a number less, n minus 1 is 1 less than n. Multiply a number even less than 1. Keep doing this until you go to 1. Okay? What's 2 factorial? 2 times 1, so 2. What's n minus 2 factorial? So 6 you start with 6, n minus 2 you start with n minus 2. You need a number 1 less than n minus 2. Bear in mind that's not 1 minus 1. Alright, 1 minus 2 minus 1 is n minus 3. Okay, don't make this mistake. Then n minus 4. Again, all the way until you get 1. If you list this all out, some magical thing would happen. Okay, n minus 2 minus 3, n minus 4 all the way. N minus 2, n minus 3, n minus 4 all the way. Therefore, they are the same. They can be cancelled out. So you're left with n times n minus 1 divided by 2 minus n. We try to get a common denominator. So n, you break the bracket, n squared minus n minus 2n, right? Then minus n minus 2n is minus 3n over 2. We factor the n out again, n minus 3 divided by 2. Let's see. Oh, this is what we want. And so that's it. Okay? Part 3 is quite simple. If there are more than 1 million diagonals, determine the least number of points for which this is possible. So you simply need n over n minus 3 over 2, which is the number of diagonals to be bigger than 1 million. Oh my god, how many is 1 million, right? 1. Okay, I believe this is 1 million. Okay, but you get the point. Okay, that's cannot be done by hand. Okay, again, this is Time Zone 2, Paper 2, 2013. You're gonna need a graphical calculator to solve this. You know, you would plot this as a graph. The left-hand side ones, the right-hand side ones. Look for the intersecting point and look when is this graph above this straight line. Okay. This is some calculator techniques. I've been showing quite a lot of calculator techniques. Okay, maybe not a lot, a few. Should be good enough. But since this is a special edition for permutation and combination, this is it. This is where I would stop. And I hope I can do something like this in the future again. And I do appreciate you to send me some comments and requests on anything you want to do. It could be not IB at all. You know, so as long as it's about some math exam available in the public, and if I can get my hands on them, I would really consider doing it and do some breakdowns on it. So, well, Happy New Year.